The third and last type of hydrogen bonding is the strongest. And this involves a hydrogen atom that is strongly bonded to a highly electronegative atom and an unshared pair of electrons of an electronegative atom nearby. Okay, so let's see what this means. So, perfect example of hydrogen bonding is water. So here I have hydrogen that is attached to a highly electronegative atom, oxygen, and it is attracted to the hydrogen is attracted to a unshared pair on the oxygen. Okay, so it's a special kind of dipole that is in particularly very, very strong. So what do we mean by a highly electronegative atom? Well, I can give you a hint on how to remember this. I don't know if you've seen the movie E.T., but I hope you have, and one of the famous phrases from that movie is phone home. So the electronegative atoms we're talking about, fluorine, oxygen, nitrogen, of course attracted to hydrogen. Okay, so if you have this situation, you're going to have hydrogen bonding. And we show hydrogen bonding as dashed lines. So dashed lines between adjacent water molecules. So here you have a water molecule, and what you can see here is it's not just one water attracted to another water, but there's a whole network that gets formed. So if you imagine this being what the surface of a beaker of water looks like, it's going to take a lot of energy for this water molecule to break apart, to break off from this cluster and go off as a gas, because it's attracted to all of these waters. So hydrogen bonding is very strong. Okay, so let's take a look at my favorite ever animation. I hope you like it as much as I do. Alright, so here we have a water molecule. It has polar ends, right? Negative and positive. Okay. So water is a love story. It is attracted to the positive sides of the water, or attracted to the negative sides of the adjacent water molecules. I hope you like that as much as I did. Okay. Alright, so here's one more chart that shows the comparison between a variety of molecules, and what you can see is as you move up here in boiling point, you have more and more polar molecules. So the more polar, and the polar end would be the red side. The more polar the molecule, the higher the boiling point. Alright, so let's take a look. This is a chart that summarizes everything we've talked about in terms of attractive forces. So we can have intramolecular forces and intermolecular forces. So if we're looking at attractions, ionics are the strongest because they're between charged ions. They're actually full charges. It's the strongest. They occur in ionic compounds. In covalent bonds, the strongest in molecular compounds, the strongest thing is the covalent bond, which is the bond, of course, between two adjacent atoms, right? So the OH bond, not drawn very well, within the water, right? The OH bond within the water. That's the strongest. That's an intra, it's part of the bond. And the triple bond is stronger than the double bond, which is stronger than the single bond, as you can imagine. And it's in molecules between atoms. And then the next strongest are these intermolecular forces, the strongest being the hydrogen bonding. And it is between phone home, right? Highly electronegative fluorine, oxygen, and nitrogen, and a hydrogen on an adjacent molecule. We can have dipole forces, which can be very strong or can be not so strong. It depends on the polarity of the compound. And all polar molecules have dipole-dipole forces. And of course, the weakest type of dipole-dipole force are dispersion, or of intermolecular forces are dispersion forces. They are intermolecular, they're the weakest, and they exist in all molecules, whether they are polar or nonpolar. Okay, so at this point we covered everything, and now it's time for you to go through, finish your packet, do all of the work on intermolecular forces, and then do the review. And when you're done with all of that, you're going to be ready for the test. Okay.